Welcome back, Hampshire chemistry students. Glad to have you guys today. We are going to be continuing our talk about acid reactions. This is after we just did a bunch of different notes on our sheet earlier, so make sure you go back to that video if you haven't watched it yet. But right now, we're going to be looking at the acid reactions homework with a little bit of quiz review at the end of it. So this is number 43 in our binder. Okay, we will be looking to grab this guy and hand it in tomorrow in class, so please make sure that we're working and finishing this guy up today. Notice we have a little bit of summary here of our notes from the other day. You can see the three main types of acid reactions: an acid and a base, an acid and a metal, and an acid and a carbonate. Okay, we can always identify our bases by OH. Our metals, well, those are just our different metals on our P table on the left side. And then carbonate. Carbonate, hey, that's one of our polyatomic ions. Okay, that's going to always see CO3 down here with that 2- charge. I'm going to go ahead and write that up here. Remember that you are an active participant in this video. You should be writing with me. So you should have your pencil in your hand right now, writing down that we have this carbonate is a CO3 with a -2 charge. So let's take a look at how we would break down one of these problems and how we'd set up going forward on working on one of these. The first thing you need to do when you look at this, where you're given the reactants in chemical form, is you need to identify what type of reaction am I looking at, which pattern am I going to follow. So let's go through here and identify some things. Right off the bat, I see HCl. That H gives me a huge hint that I am talking about an acid. Okay, all acids will have that H present inside of them to make that H+ ion. And over here, I see NaOH. Okay, these guys, this guy has a Na and an OH. Oh, that OH gives me a big sign that this is a base. So I'm going to follow a very simple pattern. We see we have the acid and base. Those are going to make water and a salt. Okay, so we did this one on our notes really quick so we can set this up. We're going to take H2O, okay, that's our water, plus the salt. Well, the salt is whoever is left over. In this case, that's going to be sodiums and chlorines. So those two will come together to make the positive and the negative ion that will form this new ionic compound. So NaCl is our salt. And we want to make sure that, hey, Na is a +1, chlorine's a -1, so that will work as an ionic compound. And you can look here, we have an already balanced reaction. 1 plus 2 hydrogens on the left equals 2 hydrogens over here, 1 chlorine, 1 sodium, and 1 oxygen. So we're good to go. This one's nice and easy. Let's try a harder one, see if we can identify what's happening in some of these guys. Why don't we scroll down and take a look at, this guy stands out here. We've got a different type of acid, and we've got a single element. Let's see how we'd set this up. Okay? So again, you want to identify right away that this H identifies this guy as an acid, the H3PO4. Li, well, if you're not sure, you could look up, hey, it's not OH. Hey, it doesn't have a CO3. It is not carbonate. So, and you can always, again, double check and say, oh, Li, that's on the left-hand side of the P table. That is a metal. So we're seeing a acid reacting with a single metal in the form of Li. There it is. Okay. So what are our products going to be? Let's check our pattern. We have acid plus metal equals hydrogen gas and a salt. Okay, so right away, I know that I'm going to be making H2 as my reaction. Okay, I can't tell you how many chemistry students miss that the hydrogen always exists as a pair when it's on its own. So lastly, we need to make our salt. Notice we've already used the hydrogen, but we do have lithium and phosphate. That's our PO4. Okay, so these guys are going to come together as LiPO4. Again, don't just assume that this is correct. Pull out your P table and check. Okay, lithium's in our +1 group. Phosphate, that is right here. Ooh, that's a -3. So that means I'm going to need 3 lithiums to balance out that positive, that balance out the positive and the negative charges in this compound. So lastly, we want to make sure we balance, because by putting a 3 in front of the lithium, that means we're going to need a 3 in front of this lithium. Okay? But so I then notice, I've got all right, let's restart that.